Sure. Just give me a minute. Okay. Um, yeah, this should be okay, right?
Yes, that's right.
Okay. So yeah, that's the title of the Hangout on Air that we planned for today. And as you can see the subtitles, we are planning to talk about areas like artificial intelligence, neural networks, machine learning, deep learning, smart search, Internet of Things, predictive analytics and big data, and we'll then go on to talking about their adoption by businesses and what are the possibilities and how could these disruptive technologies and these very major developments be used by 21st century businesses. So okay, we had actually. Artificial intelligence has been in one form or the other been around for a long time. I mean, for quite some time, but it's lately gained a lot of impetus because of several developments. And it's to give a quick definition of artificial intelligence, it is where systems progressively learn based on their experience, based on certain data and repetitive data and information that they keep on feeding on, and as a result of which they get smarter. It's a huge area, and so I'll instead of going into too many details, let me talk about, for example, neural networks and about deep learning. Now, neural networks are basically, the name comes from, it's derived from the neurons, which the human brain has. And neural networks are supposed to closely simulate, in a very simplistic fashion, the human brain neurons. Now, the neurons in the human brain they're an extremely complicated structure, and we're not going to go into that because we are not specialists into that as well. But today's neural networks actually organize there are several layers of artificial neurons which can be trained, or which, like I was mentioning, do train themselves after a while to essentially figure out a coherent pattern and a coherent data from a whole host of what I'd call very randomized inputs, in structured inputs, unstructured inputs, and so on. In some ways, it is very similar, analogous to if you visualize a child learning from various random inputs, which pours into his or her virgin senses, and that's how a child learns. Now, it's a very similar way, in a far more simplistic fashion, that neural networks train themselves over a period of time. Now, these are expected to usher in what is referred to as the age of intelligent computer systems, which learn on the job and progressively get smarter and more powerful. So as they go along, as they get into more data, they learn more and they become smarter as a result. And this is an ongoing process, which is again similar to the learning process of a human being over a period of time. So just to give an example, like for example, search. Search is one such application where search over a period of time becomes smarter, and it finally develops into what people call a prosthetic brain, or an extension of the human brain. And it is supposed to get into a situation where it is able to anticipate a lot of your needs, or what exactly you may be looking for or deciding to act on at a period of time. So that's like personalized search getting smarter. A few other examples of deep learning is, for example, if you feed large volumes of emails into a deep learning system and start labeling them as, say, very simplistically, let's say as spam and non-spam, just two labels. And over a period of time, the deep learning system is supposed to intuit, intuit based on all that unstructured, complex content which is contained in these emails, and figure out for itself what is spam and what is non-spam, and then initiate action that you may ask it to initiate. For example, put the spam into a spam folder. So that's one example. Uh, Google, for example, is heavily into deep learning systems. They've got some of the best people there, and one of the projects where they have been fairly successful so far was in identifying objects from images, and therefore be able to caption photos. Now, without being told, I mean, there are several examples which you can look up later, but without being told about what the object is, it has, for example, studied a huge volume of images over a period of time, and then it is actually able to figure out, for example, saying that this is a tree and this may be a tiger and this may be a car, and look at, for example, a particular sequence, and actually give textual captions like saying a car driving along a road, or stuff like that, a cat climbing a tree or stuff like that. So which is, it is able to do itself without being told specifically about this being a tree and this being a cat and so on. Google did one of a project on YouTube videos over a long period of time, and the deep learning systems were able to identify cats. Because there are a whole lot of cat videos which are there on YouTube, so they were able to identify cats after a period of time without being told that they are cats. Okay. Some of the other applications, I mean, I'm just giving random examples here. Some of the other applications could be in like instant, near real-time language translation engines. For example, if you over a period of time, if you train it and you utter, say, a series of distinct words, for example, in English, and you're looking for say a translation into German. So at the end of a string of words or a sequence of words, you need to send it a kind of marker saying end of English language, for example. And then the system would, in real time, start spewing out the German translation as soon as you end the English language sentence or paragraph or whatever it is that you want translated. There are, Google is into a lot of exotic projects. They have a lab called Project X, which is highly secretive, confidential, and there are a lot of projects which are going on there. Some of the projects which had come out of there were Google Glass and the self-driving car and so on. Now they have a project called Project Calico, which is supposed to be extending human lifespan, and it uses deep learning techniques. I do not know too many other details. Some of the other envisaged areas are like deep learning systems which can learn complex computer games, of course, deep learning has also been utilized in self-driving cars and in robotics as well. So that's an overview of neural networks, deep learning, and I will possibly